Okay, I think it's a good time to jump in. I see that some people are still popping on to the webinar. So as you're doing that, we've got some instructions up for while you wait, but we can do that now while you get logged on. But I wanted to introduce myself to everybody. My name is Jill Olson. I work with EIE at the Museum of Science in Boston. We create STEM curriculum products and professional development for students in grades pre-K through 8. And we are so excited to have our friends from MindLabs here to join us today to share some really fun ways to think about augmented reality. So I'm going to lead it to my friend Amanda Thompson to go ahead and introduce herself. And I'm going to be, basically monitoring the chat. So if you've got any questions, thoughts, or ideas, please go ahead and put that in the chat tonight. We are not going to be using the Q&A function, so just chat as much as you'd like, and I'll respond in there. Go ahead, Amanda.
Well, good evening, everyone. Thank you for joining me. And as Jill introduced me as my real name, Dr. Amanda Thompson. I am the CEO of MindLabs and working with this company for about 3 years to put together the resources that we have here. But I am in character today, and Halloween was close enough. You'll probably forgive me for that. But I often appear in videos, etc., as one of the lead characters in our experience, which is Dr. Pixel over here. So Dr. Pixel is one of the 4 main characters that you'll see today in the slides as we work through it. If you do have a chance to download the app, there's quite a few places where you can actually interact with your computer screen or whatever screen you're watching this on with if you have a second device, to see how the augmented reality actually works together. So grab that app, MindLabs Energy and Circuits app, and we can get started from there. So Jill, did you want to do this one as well?
Sure. Yeah, there's so much we could say about what we do here at EIE, but I think a nice way to sum that up is to talk about the engineering design process. This is a tool that we teach students in pre-K through 8th grade that they can use to solve problems, whether it's a problem in engineering, a problem somewhere else, maybe outside of the classroom. This process is a cycle where students, and frankly, even grown-ups, ask, imagine, plan, create, and improve, all to create solutions to different problems. So we wanted to invite our friends onto this call because there are really cool connections between the engineering design process and what we all do.
Wonderful, thank you. So we really did frame what we worked on in AR around the engineering design process as well. So we think we fit in really nicely with a complement to curriculum providers like the Museum of Science. But we have a few areas where we believe that we provide some extra added value. So first of all, when we work with AR, it gives students a chance to have a lot of early success and confidence with their first interactions with some of the materials. And I have quite a bit of experience in working with kids and circuit materials as elementary learners, and there can be a lot of challenges when they're first working with the physical materials, getting things to work. So augmented reality can give an opportunity to build confidence with those beginners. And that's what we'll focus on today. I wanted to also just briefly touch on the 2 other sessions that we'll do. So the other 2 places that we like to talk about AR providing a really great added value to the hands-on science and STEM experiences is troubleshooting. So troubleshooting is one of our focus areas. And next week, we'll have our Purdue professor that works on this in her research talking about troubleshooting. And we have troubleshooting as a central feature of the app. And then the third one is around authentic design practices. So the engineering design practice out there in the real world uses a lot of digital tools. And so we think of our tool as a good place for students to begin to build, iterate, improve, and troubleshoot their own prototypes before maybe they go to a physical build, or it can be the final product as well. Another nice thing that we'll talk about there is the ability for students that are located not in the same place, and this is really big right now, or they're at different tables, they're not directly interacting with each other, can actually be collaborating with a digital design on different devices or from different places. So that's kind of the third iteration, collaborative design. And then we wanted to highlight how the products that the Museum of Science offers, like the alarm circuits, there's other light up the night resources, etc., parallels well with the product that we offer here. And it's just a small game set that goes with the augmented reality. So you'll see how we use it today as we talk through these topics. But the topics are also not, focused only on what happens within the app. We're going to talk about the basic concepts today, and that's what leads us nicely into our objectives for the day. So the 3 things that we'll try to accomplish today with our energetic agenda is, number 1, to define energy. So what is energy? How is it talked about in standards versus maybe in practice? Talk about transforming energy. So that word of producing and consuming energy may come up a lot. We'll talk about how that connects to the actual idea of transforming energy. And last, we'll do a little bit around actually building circuits. So that's where we're going to go today. So first up, everyone knows about energy, but once you try to nail down an actual definition of it, it gets kind of challenging. So think about for a moment how you would actually define energy to a new learner of it. Even in the standards, they actually don't give a refined definition of energy. They kind of talk about the different types of energy, but we could define energy at an elementary level of energy is what makes things happen. It gives us the ability to light up, and here's our little robot characters, to light up, to make noise or shout, to blast off, or have heat, and to run or move, and more. So that's a nice elementary definition of energy. And a more scientific definition, if we want to go to that, is energy is the capacity for doing work, where work can be defined as all of these things that are listed here: light, sound, heat, and motion. All of them could be defined as work. So the capacity or the ability to do work. Now, when that kind of becomes difficult to think about when you think about something like electrical energy or the energy in circuits. So in that case, the work is actually a kind of a motion idea where it's the movement of the electrons in the atoms through the circuit. So it's still a movement idea. It's just those little tiny electrons that are moving. So when I'm talking about this with kids a lot, one of the things I like to do, and I have my own 10 and 12-year-olds who have been my best product testers, and they show up a lot in our materials as well. One of the things I like to talk about with early learners about energy is, first of all, what comes to mind when they think about energy. Again, it's a concept people talk about a lot, and the world needs energy every day, but what are some of those places, or what were those first thoughts you'd have about where you'd go if you needed energy? Or what are some of the sources of energy in the world? Okay, so think about the list that they might come up with, a group of young ones might come up with, or the list you'd come up with yourself before I pull it up. So here would be some very common examples. So energy comes from, if I want my car to go, I have to go put gas in it. So gasoline would be a source of energy. Batteries would be a source of energy for our cell phones or our toys. The sun is a source of energy for all the plant life on Earth, right? As well as, a basket of food, the energy for our bodies. All of these are actually examples of chemical energies. So most of the things we think about as sources of energy are forms of chemical energy: food, gasoline, and fuel. Okay, so of course, that's only one of the forms of energy, and we can list a bunch of others as well, and we already had our way towards starting onto our list. Now here, when I'm showing these slides, one of the things that you'll see come up is this little icon here that says that you can look at this in the MindLabs app. So if you open the app up and you go into the area, the create area, and this is the icon that says open a single player room, you'll see that there's an opportunity if you are interested in opening as well multiplayer rooms. But today we'll just talk about the single player room. And you point your device at this image, you'll see this image actually come to life and animate. So these are what we call idea cards, and they give kids the opportunity, if they're looking at an idea, these little cards that come with the app, to see the idea animated. So they can look at the card offline and just see a fixed image, but when they look at it in the app, it animates. And it also gives them the opportunity later down the road, if they are looking at a static image, to still have that animation going in their head. So I just wanted to give a chance. What I'll do today, I know many of you probably won't have the app up and ready to go yet, but this is what you would point to. So I'll give an opportunity for anyone who has the app to look at this, this image under their app. And then I'll click to what it actually would look like. So here is what the card would look like it was doing if you were viewing it under the app. So it's going to be showing the little robot here running. This is our robot Adam. So again, our forms of energy, if we're starting to list the types or forms of energy, we have chemical energy. We see here this card demonstrating light energy, sound energy, heat energy, as well as there's kinetic energy or motion, electric energy, which is sort of the theme of circuits a lot of times, although we have batteries, again, being the source of chemical energy, and nuclear, as well as potential energy. Now, I've been an educator pretty much since my very first job as a piano teacher. So I know that whenever I'm trying to teach someone something, I want to know at least one layer deeper than what they might know coming in. So the next slide I'll pull up is pretty busy, but it's one of those slides that lets you get a little bit deeper into each of those types to answer the why questions that the kids can dig into. So when they're asking more about energy, we'll provide this resource that gives just a level deeper into those different types of energy. For example, we talked about electric energy being the electrons moving around a circuit, and they're moving because of a magnetic attraction or an imbalance in the electric charge in the atoms. So that causes the atoms, the electrons to want to move from one side of the battery around our circuit to the other side of the battery, which is insulated from them inside the battery. So that'd be an example of electric energy. Heat energy is, again, a movement, particles bouncing into each other. Sound, also kind of a movement of vibrations of the air molecules. Potential energy coming from where a part or how a part is positioned, whether it's above ground, so it has gravity, a spring, which is compressed or stretched, and magnetism, like we talked about with the batteries. So our first objective was to talk about how to define energy. So we've defined energy, and we've talked about several different types of energy as well. Another concept that is kind of often misconstrued or misunderstood is the idea about the conservation of energy. So energy cannot be created, nor can it be destroyed. And I had a little note here, a fact that has disappointed many villains. So here's our villain, Dr. Stonebreaker. You know, we're always seeing villains in the comic books trying to, you know, create some device that around energy. So if we adhere to this idea that energy cannot be created or destroyed, the first question that might come up is, what happens to batteries then? You know, what happens to our batteries when they run out? Or, you know, where does that energy come from? And so it cannot be created or destroyed, but the idea is that energy can be transformed. Okay, so it can be transformed. This again is another card that we have in the set that kids can look at under their device to see this move. And I really, really like how this one moves. So I'm going to show you this one. So the idea of energy transformation, the energy in the battery is saved as chemical energy, and then it is transformed to electrical energy as it moves through the wire. And then when it reaches its where it's going to be transformed again for its purpose to do some work for us, it's transformed to light, to heat, or to sound energy. So you'll see that card sort of cycles through that to show the kids that transformation process. Okay, when energy changes form. All right, I'm trying to keep an eye on the chat too in case there's some questions. So again, if you look at this under the create space, you can see this animation pop up. And then when the kids later look at this card, they'll think, oh, I can kind of mentally picture this transformation animation. So when we talk about, again, transformation, we have to kind of put that in scope with the idea, or what we might hear, energy production and energy consumption. So another great question to ask the kids about is, how do we produce energy for our daily needs? So where does it, what are those sources that we think about, or energy production? And so again, I'm going to just take a little pause for you to mentally think of the list you might come up with to answer that question. See what kind of things you'd come up with. So where is that? So the energy production examples that I have up was a farm. It produces our food. There's coal or oil. There's windmills. There's dams. There's nuclear energy. There's solar energy, right? And so again, we're thinking more about that as a transformation process. So a farm transforms the sun's energy into chemical energy in the plants, right? So energy from the sun transforms to chemical energy. Coal powered power plants transfer the chemical energy that's inside coal or oil and transforms it into electrical energy, right? So that's the transformation. A windmill or a dam transforms motion into electrical energy. You're spinning the turbine. So, you know, this is just a demonstrating that these different sources of energy are really transformations. Solar energy, again, the sun's light into electrical energy. So these are some good examples of showing how production is really another form of transformation from one form of energy to another. And we store these forms of energy as well, kind of in between. On the other side of the production equation is the energy consumption. So energy consumption is also transformation. So how do we consume energy for our daily needs? So if you think about the different places we might consume energy, right? Hopefully you'd come up with things like, you know, a lamp is going to consume energy, or here's one, you know, we're actually creating sound, so that has to come from something. We have our car is a common one, and most kids are pretty familiar with that. So again, we have the other side where the electrical energy comes in, transforms back into light energy. And this is where a lot of our circuits, right, come into mind. And we'll start there with our circuits. Here we have motion energy of your arm transferring into sound energy. And in the vehicle, we have the chemical energy of the gasoline transforming into the motion of the vehicle. So that's the transformation there. Now with the little robot friends, we have the chemical energy and their batteries transforming into all the things we saw on that card, where they're lighting up and blasting off and you know, shouting or having lasers and all those things. And of course, humans as well transfer the chemical energy of their food into motion to do all the fun things we like to do, like play soccer or you know, video games or whatever we like to do. Make sound too, like I am right now. So that's the idea of energy transformation. Now, a lot of times this is covered in a classroom or at home. We want to do circuits with energy. So transformation, what is a circuit? How does this all connect to being a circuit? So what is actually a circuit? What do we define that as? A circuit is the path that electrical energy follows when it transforms into something useful, like, for example, light. So a circuit is just simply the path that the energy travels on. Okay? But there are things that must be true about the circuit for them to work, and that's where maybe the first sort of steps in doing a circuit exercise at home with your kids, or a circuit activity at home, is to make sure that these certain properties that must be true about a circuit are followed. So a first thing about a circuit is it must be closed. It must be connected in a special way in order for it to work. So again, another concept for kids learning these things is the idea of a closed circuit. And as you can guess here from my little create icon, we're going to see this animate here in just a minute. But a closed circuit is a complete path that the electric energy can flow through in a complete loop. So all the way through that little circuit, it has to be connected in that certain way. So here's the little animation that goes here. It shows us that it won't light up if it's just hooked to one side of the LED or even just one side of the battery. It has to be a complete loop that includes both sides of the piece and both sides of the battery to light up. And that would be our definition of a closed circuit. So an open circuit is one that does not have that complete loop. All right, now next up, I was going to show a quick video about some of this stuff at home. So this is a clip, so it's not going to be as smooth as the full episode. There's a full episode of this available on YouTube. Here's now Dr. Pixel, and this is little Pixie is what we call her. This is my 10-year-old here that's going to show us a little bit about what circuits might look like at home. So I'll get started with that.
All right, let's look at how to make a complete circuit. So the important thing about getting a circuit to work is that the energy can flow all the way around in a complete loop. So out one side of the battery, up through the piece, and out the other side, and down into the opposite side of the battery. So one of the easiest examples of that would be to hold this AA, which we know has a plus side with a button and a minus side where it's flat. My assistant's Pixel here is going to hold it. And I'm going to just see what happens. I want to make one wire, which is connected to the light bulb, touch one side of the battery, and the other wire touch the other side of the battery, like this. This will be a very simple circuit that you can complete at home. Okay, now another favorite circuit piece inside of little sets is often a little LED. And an LED has two sides as well. These two different legs, but you'll notice that one leg is longer than the other leg. So the longer leg is actually the red, think of that as the red, the side that has to touch the plus, and the shorter one is the minus. Now,
so let's see. Shorter one has to touch this side of
the minus side.
And
yep.
The
plus. Okay, show us. So a very easy thing you can do with LEDs is just hold it to either side of the battery.
And it'll just turn on. Really simple, and it depends on the thing, but you can also use it on a flashlight, just put it in, and it actually will work very well. I think that's what it's like, the finger rings.
Oh, inside of a finger ring, yeah. So if we put it on, so she has one leg touching the plus and one leg touching the minus. If you switched it over, it won't work. So that. All right, let's
finger rings.
Oh, inside of a finger ring, yeah. So if you put it on, so she has one leg touching the plus and one leg touching the minus. If you switched it over, it won't work. So that can be a little bit frustrating if you're working with LEDs at home and you didn't know that. That they have to be facing, they have to have the correct orientation to work. So to make your circuits work, you have to worry about having some energy, like the energy in the batteries that we talked about. You need to worry about it being a complete circuit, so it going from one side of the battery to the other. And in this example, we'll see it can go up. It starts on the plus side, up the leg through the LED, back down on the other leg, and through the minus side of the battery to make a complete circuit.
Round again.
So that's our little series that you can look at with your kids. It was kind of designed to be looked at with your kids to see how circuits could work or things that you can do at home pretty easily to put them together. So that's an example of some of the resources that you'll have available to you after the webinar. Now, I also wanted to give you a chance to actually look at how you build circuits in augmented reality. So this is just a screenshot where I have some of the circuit cards looking like they're sitting on the top of a tabletop with your paper and pencil here. Now, when you're inside the app, if you point your screen at these cards, you'll see, and if you're following along, you can see that this robot card has a 3D little robot appear over the top of the card that you're looking at, and she's kind of like your guide in the space. And you'll see if you're looking at these other two cards, they have also a light bulb and a battery that appear above them, kind of like always the example with augmented reality is Pokemon Go or Snapchat, where you see these these little figures looking like they're out in your space. With this case, with these cards, it appears as if you have these circuit pieces just sitting right there on the tabletop with you. And you can connect the circuit pieces as well. So if you're looking at the cards in the create area, you can add the light bulb by tapping a little button on your screen that says plus. So add this to my build space, and a AA, you can add that in. And another nice thing about augmented reality is those light bulbs aren't going to blow out. Those batteries aren't going to go dead. Well, they can in the app, but you can respawn them and they work again. So that can happen a lot with physical materials, especially with those little light bulbs that I showed in the video. We've burned out many of those at our house using them, and always dead batteries. If you have kids at home, that's also very common. But with augmented reality, you can kind of experiment with things like what happens to a battery, what happens to a light bulb if you put too much power onto it. And there's no danger. So safety is a nice feature of augmented reality as well. But once you add these into your space, you can, on the screen of your device, drag your finger to create wires to connect the different pieces and see what happens. So this will give you, if you again are following along, you have the opportunity to do that. And if you aren't doing it now, this slide is going to be available for you to try it as well later if you'd like to. And that really brings us to wrap up and look at some of the resources that we've made available to you to follow up on these topics. So today's resources will be available at this bit.ly link here. So if you want to copy down that 34VJLFX for the bit.ly link. And I believe that Jill's giving the link, so that's the longer link. You can find it on our website. So I have going to post all the webinar resources going forward today and going forward there. You can find the YouTube videos, the link to the YouTube videos. We also have available, if you subscribe to our newsletter, we have a set of learning slides. So we have 5 full lesson plans that can be used, and they're really slide sets that can be used at home as a parent, or in a classroom. It's been used in classrooms as well to work through these topics, and they're all framed around this fun storyline of our villain who's trying to disrupt everyone's circuits, and the 2 robots are the trainees of Dr. Pixel, who's helping them learn and understand these different circuit principles. The Museum of Science has a plethora of great resources as well at eie.org. They have curriculum, they have individual classroom material kits that you can order there as well, and they have face-to-face or virtual units. So again, there's our YouTube channel, there's circuit kits that are available to build these after you've designed them and learned about them. And with that, I invite you to make STEM possible together, and thank you for spending 30 minutes of your Thursday night with us.
Thank you so much, Dr. Pixel. It was so fun to hear from you and to learn with you. And we hope that all of our attendees tonight learn something, or at least plan to, take these resources with them as they go and learn even more and share back out with us. So if you want to come back and join us for more fun, next Thursday and the Thursday after that at the same time, we'll be back here where Dr. Pixel will walk us through some whole new ideas and fun new things to learn. So we really invite you to come back and join us, and thank you for your time tonight.
All right.
Thanks, everybody. Have a great evening.
Good evening.